both of them are the highest, or almost the highest in this past several years. So how is that happening? So as I just said, WeNetwork is a specialized conference or community that benefit a lot from these kind of collaborations. A lot of great works are coming from, actually they come from collaborations like BBR and even DCTCP from Cisco, right? They're different great works. They really come from the collaborations. But on the other side, if your students, right, if you are, or you are the student, you ask your professor the question, like, how can you publish papers just because that paper is one of the production results of the production team? It's not that research-oriented as a student can lead. So how would you balance this strike between the collaborations and the research efforts or the values inside the papers? So to this purpose, here we have several questions that we will discuss later. So to these questions, we are very fortunate to invite the authors of 4 papers in this year's SIGCOMM', from UIUC, Harvard, Cloudflare, Alibaba, and Georgia University, also Amazon Prime Video, that they will share their experiences and lessons on how their collaboration starts, and what is the story behind the paper, why there is going to be collaboration, what is the students' efforts in that collaboration, and what is industry roles in that collaboration, how is the effort that is put in from both sides. We hope that this will help the community to understand better on how, if you're a newcomer to this community, how this collaboration will happen and will affect your the next generation or new results in the future. All right, so yeah, that's it for my side, and we will have a open mic or discussions after all the presentations, and you can raise no matter what questions you are going to face to our speakers, and they will come up or share their stories for your reference. All right, so let's invite our first speaker, Amar Tahir from the UIUC, to present his story.
So this is the left, right to switch up, and it's not up, down. Okay. Down will stop it.
So the right goes
down. Yeah.
Okay. Oh, looks good. All right. Hi, folks. I'm Amar, and I'll be sharing our collaboration story on our project BCPQP, which is a collaboration between folks from University of Illinois and Microsoft Research. So our paper is about enabling policy-rich rate enforcement efficiently. So what I mean is, for example, ISPs rate limit users' traffics routinely, for example, 200 Mbps per user. But now I also imagine that they are implementing per-flow fairness within that. And we're able to do this at 7 times lower cost than status quo mechanisms. Our talk is on 8th August in the same room at 10 a.m. Please come visit. Please come to the talk if you want to learn more. All right. So the motivation of this work comes from the fact that Microsoft was already designing traffic shaping solutions for cellular service providers, where cellular service providers wanted to rate limit each mobile user's video streaming traffic to 2 Mbps so that they could kind of manage their radio resources efficiently. And they also wanted to implement per-flow fairness within each aggregate. And their reason was that doing this helped with video QoE. Okay. And their existing solution, which they had, was inefficient and slow. So they wanted to see how we could do better. And for myself, I had previously, in my previous work, CRAB, which was published last year in NSTI, I had explored how we could enable user-driven rate-sharing policies on users' downlink internet, and without any support from ISP. But I had been curious about why ISPs do not allow such control for the users to kind of implement these rate-sharing policies to divide rate between their applications or users. And also, what could we do to enable ISPs to support such policies? So this is what our timeline for our project looked like. I started talking with Pratish and Elias around right after NSTI last year about the problem. And then I started my internship in around May or June, yeah. And I started off with finding we started off with looking into the existing solution and finding bottlenecks where our co-author and industry contact Mike was really helpful in helping us understand what the code looks like, and also my mentor Ilias was very helpful in helping me pinpoint what were the bottlenecks. And then my other mentor, Pratish, had the idea to use phantom queues, which could enable the same policies with much higher efficiency. And I spent rest of my internship kind of understanding behavior of different flows with this idea. And we saw that a lot of things were breaking, so we were trying to figure out how we can make it work. Oh, this is very weird. So by the end of internship, we had like a point solution where we could do rate enforcement with per flow fairness efficiently. And after my internship, when I went back to my advisor, my advisor and also Pratish, my advisor Radhika and also Pratish kind of motivated me to generalize the solution that we had to other rate sharing policies. And they also encouraged me to kind of find bounds on the rate and policy enforcement guarantees with our solution. And then in just 2 months before SIGCOMM', we kind of solved the last piece of this project, which was designing a mechanism that controls the burst with policers. And then I spent remaining time implementing and evaluating our design, and which where my co-authors and industry contact was really helpful in making sure that we implement a efficient industry standard baseline. So for the lessons I learned, the first thing I learned was, which is like a cliche, but I learned that many problems become more apparent at the scale of industry, and the solutions also become more appreciable at the scale that industry operates at. So for example, I had no idea that enabling per flow fairness in video streams could help with QoE so much, but at the scale that these cellular service providers operate, they had kind of made these observations. Similarly, shaving just a few CPU cycles can lead to massive cost cuts, which was again straightforward but interesting. And my my academic advisor helped me making sure that that a generalized solution is just a few steps away. For example, we had per flow fairness, but we could spend a bit more time coming up with kind of mechanisms such that we could support other rate sharing policies. The other lesson I learned was that it's always a good idea to ask questions. Sometimes I learned more than what I intended with that question. And lastly, I should collaborate more because again, good research is product of differing opinions. With that, thank you. Yeah.
All right, thanks. So we will put our questions in the end of the session. So the next presentation is coming from James Larish from Harvard and Cloudflare. So one knows this left right is switch up and down. So this is the next. This is the previous.
Okay. Thanks. Everybody hear me okay? Cool. All right, so hey everyone, I'm James Larish. I work at Cloudflare on the research team. I made this for PhD students who want to make the most out of their industry internships. Okay, so who am I? I was a PhD student myself up until January of this year. I graduated in January. I started my PhD in 2017, and during my PhD, I did an internship at Cloudflare for over a year. I started in 2021 and ended in 2022. And I'm here presenting my internship project actually on Thursday in programming networks. It's called Topaz. Come see. And as you can see, it took a lot longer than 3 months to get a paper out of my internship project. So I now work full-time at Cloudflare Research. We work really closely with engineering teams to get research projects actually deployed as well as published. So this talk was shaped by my experiences there. All these opinions are my own, though. All right, so before talking about succeeding as an intern, should you do an internship at all? In my opinion, yes. I think you should do an internship early. I didn't do an internship till my 4th year. I wish I did one in year 2 or maybe even year 1. I've heard some people say, you know, internships just delay graduation because you often don't get a paper out of it. I think that's a mistake. I think you should still do an internship even if you don't get a paper out of it because why, right? So 1, obviously it'll help you make connections. But 2, it'll also expose you to some real problems that I think you can use and build on later to write papers during your PhD. Also, you'll make some money. Money was a big stressor for me during my PhD, and the internships really helped. And finally, if you do an internship PhD, a PhD internship in industry and you realize that you don't like it or you do like it, that's really valuable information to have about your career. Okay, so you've got an internship. Maybe it's on a research team, maybe not. Here's some pieces of advice I'm going to go over. So first, rethink your definition of what research is. Second, work on one big thing. 2, assume all engineers are stressed and overworked. And 3, show, don't tell. All right, so academia is really great because you can spend multiple years building a research grade prototype that no one ever uses, and then you can publish a paper about it, and then you can graduate, and that's success, right? But your internship isn't really like that. You have a few months. So you need to recalibrate your expectations a little bit. I think at the end of the internship, you should aim to be able to say something like, I built a new proof of concept for a small percentage of traffic. I improved performance by 10%. I wrote a blog post explaining some plans for the future. And you shouldn't be ashamed if you don't get a paper in 3 months. At Cloudflare, many internship projects result in papers, often months or years after internships end. But if an intern's project doesn't, that doesn't mean that they were a failure. Okay, so being an intern is a huge opportunity. You get a few months to focus on a single problem. Most employees do not have this opportunity. They have to work on a bunch of different things. But focusing on one thing can be really hard. Some companies do a lot of cool things, so it's easy to get distracted, right? So I hereby give you permission, if you are an intern, whenever somebody comes to you and says, hey, look at this cool thing, do you want to get distracted? You can say, sorry, I'm just an intern, and you can get back to doing your actual work. The CTO of our company once said to a bunch of us interns, it's better to get one big thing done than a bunch of tiny things done during your internship, and I think that's true. I mean, sometimes a few months is not enough time to get something big fully done. Look at me, I didn't get something really big done in 3 months. But I think it's good to try to leave something memorable behind, like a concrete proposal or a proof of concept, etc. Think about it, what sounds better? I fixed a bunch of bugs or I built a new thing. Not only will it look better on your CV, but I think you'll remember the experience better as well. Okay, so a lot of great research projects at Cloudflare and elsewhere come from understanding the problems with existing systems that are maintained by engineers. So to discover and solve these problems, I recommend starting by asking engineers what they need, but I also would expect them not to be able to articulate it to you directly. Engineers are often in the trenches, fixing bugs, putting out fires, so they may not have the time or energy to think big picture about how their systems can be improved. They don't have a time to read a bunch of research papers, right? But you probably do, or at least you did. So see if you can use that research knowledge to provide value to engineers. And by value, I mean, can you reduce the number of times they get paged? Can you improve their performance for their public-facing stats? Okay, finally. How do you convince people that your project is worth doing? When you have an idea or you've started to solidify an idea, you'll likely be asked to write about it. I think that's a good idea and you should do it. But you should also expect a lot of people, like those overworked engineers, maybe not to read it as fully as you want them to. So I recommend, in addition to writing, building minimal prototypes as soon as possible and showing it to the relevant stakeholders. It's much easier to convince engineers that you deserve to mess with their systems if they can viscerally understand how it's going to make their lives better. Okay, that's it. That's all my advice. We love interns at Cloudflare. If I can help anyone in any way, please come up and talk to me after. Thanks.
All right, thank you, James. So the next speakers are from Alibaba. So Yang Ye from Alibaba and Jiang Xiaochong from Zhejiang University. So you guys are going to present together, right?
Good afternoon, everyone. I'm glad to be here to share the industry academia collaboration in Alibaba Luoshen Cloud Network. Firstly, I'm going to do a longer self-introduction. When I was in my second year as a PhD student in the Institute of Computing Technology, Chinese Academy of Science, I joined the collaboration project to study the vSwitch with Alibaba Luoshen Cloud Network. So you may say, fortunately, that project provides me with a solid topic and the research direction in my research career. So after my graduation, I joined the Luoshen Cloud Network as a research, but also the development engineer for Apsara vSwitch. So you will see that in the spectrum of industry academia collaboration, I have changed my identity from the academy to the industry. And I also gained experience on both sides. I mean, for example, I know what kind of problems are suitable to do research and to write a paper, and what is the research problem or the engineer problem. And also, I know where is the real gap between the paper and the real deployment. So in the past years, with more and more students, especially PhD students like me, join the Alibaba Luoshen Cloud Network, and more collaborations are conducted with universities. We have presented 9 widespread, wide deployed systems as the figure shows. And we published more than 10 high-quality papers like SIGCOMM', SDI, and so on. But more importantly, we also helped at least 20 students to deeply engage in the cloud network area. So the research collaboration in Luoshen Cloud Network made the contributions for both the scientific community and the industry in the talent fostering. So you're welcome to go to our sponsor booth to learn more about our systems. So in the next, I would like to invite our paper collaborator, Xiaochong Jiang, a fourth-year PhD student in Zhejiang University, to talk about what he has learned and what is the story behind our papers. So let's welcome Xiaochong Jiang.
Hello, everyone. I'm Xiaochong Jiang from Zhejiang University. I'm a PhD student, and thanks to the committee for providing such an opportunity to share the story behind the industry and academia collaboration. And I have been working closely with Dr. Yang in Alibaba Cloud for recent years, and I'm glad that our collaboration paper were presented at this conference. So I will share my experience of this collaboration from a student's perspective. So the first thing I want to talk about is how I started and why I joined this collaboration. So last year's summer vacation, and I was seeking for internship. My mentor recommended me to Alibaba Cloud, and at that time I was working on a hardware processing project, and the Dr. Yang asked me to solve a problem about accelerating their vSwitch. So I joined it, and Alibaba Cloud offered me the free coffee, free meals, and free a brand new MacBook. So I really love it. And the second thing I want to share is the role I play in this collaboration. So first thing, I am a researcher from academia. So I read paper, we try new idea, we write codes, we do some experiment, and then we write another new paper. But in the industry, we are asked to solve some particular problem, and so we are engineer, we are technician. So during the last papers collaboration, we put the paper in a experience track. So we write the paper in engineer's view. So the important thing is that the thinking and the design behind the whole system. And the last thing I want to share is what I learned from this experience. So the first lesson I learned is that I can see how the code actually work. So in school we can't apply what we learn at most of the time. Much of the theory or much of the knowledge we learn may only be realized in simulator. And in industry, you can see how a real system is working. And the second thing I learned is that some issue and some bug in production can turn into new ideas. When we find these bugs and we locate it, we reproduce it, and we profile it, then we can find a potential bottleneck. And at last, we can turn it into a new idea. Thank you.
All right, thanks. And our final speaker is Zahib from Amazon Prime Video. Can you please switch to the PDF file?
Okay, thank you so much. All right, thank you. My name is Zahib Akhtar. I'm a senior applied scientist at Amazon Prime Video. And I'll be talking a little bit about the backstory for our work called SODA. This is a product of a three-way collaboration between UMass Amherst, Caltech, as well as Prime Video. Really, the origins of the problem go back to, our experience with existing ABR controllers. Back in 21, we were diversifying our content and starting to offer more live content along with VOD and live linear. And as we were doing this, we were starting to uncover problems with our existing ABR controllers. So we tried several alternates, but we either found them to be too complex or they were very hard to deploy at scale. And then some of the controllers which use throughput prediction, we found them to not be robust enough to in the wild variations that we see. So really, what we needed was a design which can give us some performance guarantees so that as we move across our content offerings, the performance remains robust. And so, obviously we were not oblivious to the great amount of work that has happened in academic circles in terms of design of ABR controllers. And so to tap into some of this expertise, we actually published a CFP in fall 2021, which was focused on this idea of developing a next generation adaptive bitrate controller. So we got a bunch of strong proposals, but one of them came from Ramesh and Mohammed's group at UMass Amherst. And so they were one of the winners for this CFP. Now I remember, after the gift was done, Ramesh and myself having a chat where we felt that, it would be good to actually continue the discussion because there were topics of mutual interest between the UMass Amherst as well as, our team. And so that's exactly what we did. So, the next summer of 2022, we opened an applied science internship position. And Kevin, who's right here, he joined us as an applied science intern, at that time a first-year PhD student. Now, Kevin hit the ground running. He came in with a lot of background in it, so that really helped him with the project. And he delivered a very impactful internship. He demonstrated a design which was feasible and it met our production needs. And that's where I also have some advice. I think going back to what James was saying earlier, that typically these applied science internships, they are settled by January or February timeframe. So you still have about 2 to 3 months lead time before you start. Use that time to prepare yourself for success. Ask your mentor or your prospective manager what you can do to actually be in a position that, once you come into that 12-week or 14-week period, you're able to make the most of it. So going back to the topic at hand, once Kevin was done with his internship, he went back to school, and then Ramesh, myself, Mohammed, Kevin, we had another chat. And we felt that, the paper, we could actually turn this into a formal paper, extend it a bit, and it would be a nice thing to actually share with the community. And so fortunately for us, Mohammed and Adam had already been talking about these ideas around theoretic performance guarantees in context of online convex optimization. And two of Adam's students, in particular Yiheng as well as Nico, they had done some interesting work in this space already. And so really they provided the heavy lift in terms of proving some of the theoretic performance guarantees that we needed with the ABR algorithm. So in the end, it was a tight-knit collaboration. I think all of the teams, the 3 teams over here, we worked in unison to put this paper together. And I think what we have right now is a very nice blend of theory and practice. There are some very interesting insights in the paper, theoretic insights, as well as greatly expanded upon in the appendix. And I would encourage all of you folks to actually take a look at the paper. I think you will like it. So next, just changing gears a little bit, I want to take like 1 or 2 minutes briefly to advertise some of our science programs and also, options for folks in kind of collaborating with us. I think this may be of interest to you. So first, I want to say that we really value our academic partnerships. We do partner with a lot of universities across the globe. We also do what are called science hubs, where we broadly collaborate with faculty. And through these, we've been able to deliver significant impact in production. In terms of the mechanisms over here, so we do gift funding proposals all around, which are done like with annual calls. Outside of these, we have sponsored research agreements where we directly partner with faculty. And then, we're also open to ideas, unsolicited proposals. We're always keen on learning good ideas. In terms of the active areas, there are quite a few right now, but I think the ones which may be of interest to this community include delivery, picture quality and compression, video sports analytics. There are a bunch of other areas as well, search and recommendation, video understanding, which is a big theme right now, forecasting, automation, and so on. And then outside of these, we do have science positions. So in particular, the applied science internships, which are open in summer and fall, postdoc positions for recent grads, visiting scholars. These are typically for senior faculty. And then Amazon visiting academics. These are typically suited for junior faculty. So, I really hope that you will consider collaborating with us for your future partnerships. And then just to round it off, so Kevin's talk is tomorrow. Please do attend his talk in Accelerating the Internet Edge session. If you want to learn more about our academic collaborations, please feel free to talk to me. Furthermore, we have several science roles openings right now, so please look at the Amazon jobs page and see if there is something of interest. If you prefer offline, please feel free to email me or our senior PM for research programs, Natalie Strobach, and the emails are right here. And finally, please do not hesitate to connect with me on LinkedIn if that's your preferred mode. And that's it from my side. Thank you.
Thanks. All right, thanks for the other speakers. So the next part will be the open questions from the audience. Can I invite maybe other speakers sitting on the stage? And so that if there are any questions from the audience, you can just stand here and ask the speakers. All right, maybe let me kick off for the, sorry.
Yeah, a really simple thing to do is look at all the JIRA incidents and see if you can come up with some common patterns, or just look. I mean, so at Cloudflare, we use like a chat program. If you lurk in their chat room and there are constantly problems with a particular system, then that's a good signal. I think the trickier part comes when you're trying to, I think I'll leave it at that. Yeah.
Okay, cool. Thank you.
Yeah, maybe let me start with one question, and I can invite one of you, you guys answer one by one. So my question is, it is believed that paper from industry or paper at least with industry experiments are easier to get accepted. How do you think that?
I don't think I'm.
Or do you think it's a common practice or it's a right way?
So I think at least with our work, maybe like sometimes with the industry work, maybe it's easier to motivate the problem. I would say you don't have to do like a lot of heavy lifting there, I guess. Yeah, I think other than that, I haven't worked with like experience papers. Maybe like I think there are like a lot of insights there which like academia and industry both can benefit from. But at least in our work, maybe I think we, compared to my previous work, I didn't have to like worry about motivating that problem a whole lot more.
So I would say that industry results or production results add value, but at least from our side, we have a publishing tenet which is reproducibility. This is like our tenet. We cannot publish, or it's hard to actually get approved if the paper is completely driven by production data. So even if you look at Kevin's paper, I think bulk of the evaluation is actually done on open source data. We have a very small section for production, and I think that's more strategic rather than the evaluation section. So I think it really depends on how you want to publish your research. If the idea is to share the idea with the community and be able to let them reproduce, then I think the dependence on production data should be minimized, and at least that's the tenet that we follow.
I would answer your question, yes. I think it is easier to publish industry papers, especially systems-focused papers. I think it's easier to motivate a paper from industry because you can say things like, we are a big company and we have this problem and we solved it, as opposed to trying to convince reviewers that a problem really does exist and is worth solving.
I agree. And I think the answer is yes. Just like example, if you have 10 missions that you deploy the system on it, your words are nothing. If you have 100, that someone may think about if you are right. But you have 1 billion missions that your words are right. And I think to submit an industry paper, perhaps no one will judge your motivation. And I think the large-scale deploy experience that is used to be acceptable by all of the reviewers, I think that is the opportunity of industrial papers. So.
Yeah, I think it's up to the value behind the paper. So a good research paper has some fancy idea, and they are definitely easy to accept it. And some industry paper, they are describing some system that are deployed for a couple of years. So there are many, corner case, many situations they come across. So I think these experiences are very valuable. So I think it all depends on the value behind the paper.
Yeah, this is Qiao from Xiamen University, China. So I just want to throw in maybe 2 suggestions. One would be, I think this is definitely a great question, but it might be better to argue whether this is really a question or not by looking at the data. Maybe we can contact, for example, the PC chairs from maybe the past 10 years and to see, and then about all the submissions that contains at least 1 person from industry versus purely academic, and then basically try to plot some figures. That would be very interesting to see. And another comment, I think in general I agree with that. Papers with industry collaborators tend to get published easier because they are real problem, right? But on the other hand, does it mean that that is essentially is more like a positive reinforcement, right? So basically, since we need to get published, we need to find real problems. Since industry have real problem, then would eventually, it might be looking into the trend to see, is there emerging or growing trend that more and more people will try to hand down people from industry and then, hey, let's work together, and what problem you have, and let's write paper together. And in the extreme case, would either be one day that all the papers are done with industry collaborators, and does that mean that industry actually dictate what need to be created, what need to be creative, like something new? That I just want to throw in my 2 cents. I don't have answers on that. Yeah.
Sorry, just for the audience that come to the this room in the middle. So we have some statistics in the beginning of this session. And in this year, I think also we have talked about it in the morning. The experience sessions acceptance rate is about 1/3. and the average is about 1.6. So if you want to know more, I will post out the data and slides for the statistics later, maybe on the website.
And not just the experience track, right? I mean,
Yeah.
there are research papers that
Right.
done with the industry. Yeah.
Cool. Hey, I think, I mean, no, I just want to throw a grenade there. You guys are too polite and agreeing with everybody, so I wanted to throw something controversial. So two things, right? One is, I think, and I'm curious to hear our experiences, right? Sometimes industry papers, industry collaborations have a problem where the result is not conducive or not aligned with the business interest. And the question is the student or somebody has to like either redact or go through like a publication clearance process, or the data has to be delayed and so on. I think it's sort of presenting a too rosy a picture of like industry academia collaboration. So I think there's got to be some reality there. The second thing I would throw out, again, going back to this point about, hey, is everything going to be industry and so on, right? I think we should be careful about what's often called called like the street light effect in science. Somebody goes and shines a street light and everybody goes there. And I think if you look at the room, if you look at the conference, if you look at the program, there's a few industry voices here. There are many, many more industry voices that are not here. So there is like we are very, very guilty of a streetlight effect where there is a handful of industry expertise or when the community sheds some light on some set of problems, and then everybody sees a well-defined problem and goes and like the rest of the academia go there. There's a lot more to networking and like communications research beyond the light that 4 people shine. So I think it's very, very cautionary about like the streetlight effect. But also, I'm curious to hear your experiences. Like you're painting a very, very rosy picture of industry-academia collaboration. I'm pretty sure all of you have gone through like clearances, lawyers, and IP and all sorts of crap. So I'm just curious to hear your experiences. And yeah, yes, it's okay to be like controversial.
No, thank you so much for actually bringing that up, because it does take a lot of work to actually get these collaborations off the ground as well as get these papers over the line. I know, Mohammed, Ramesh, and Kevin, when we were working through it, the paper actually had to go to all the way to the VP to get the approval, right? And that's the way the industry is, right? So, but that's the risk that was on me. I had to mitigate that. That was my responsibility because we had to do it for our PhD student, actually 3 of them, who spent a lot of their time. So you're right in pointing this out, that this is a challenge because industry is driven by their own needs and not necessarily by research, for instance. But I think it really depends on if you can convince your leadership internally, and there are some guardrails that we put in place to mitigate their concerns. The first thing we do is that we try and file a patent. Because once the IP is protected, then it's easy to make a case that we can actually release it because the patent is going to be public anyway. And so that's the first thing that we try to do. And then the other thing that we have in place right now is that before we start a project, we do what is called a pre-approval process. So that pre-approval actually goes all the way to the VP, and we tell them, this is what we are going to be publishing. Are you on board or not? And they can kill it right away. And so we know that this is the no-go area. So these are some of the things that we put in place, but your point is very valid that this is, there is actually a lot of work that needs to be done, which is behind the scenes. It remains hidden, but anybody who's actually done these collaborative papers knows that that's a drill that you have to do.
Yeah, the only thing I would add to that is the other thing people don't talk about often is if you are a researcher, you did the work, right? You did the research, you deployed the system, it's really good. Writing the paper is usually not on anyone's roadmap, so you need to make time to write the paper yourself, which kind of sucks sometimes. To go to the streetlight comment though, cynical view, this has already happened. Like we are, NSDI, SIGCOMM' are dominated by like 3 companies, and I already think we're at a point where if you are not working with one of them, you're at a disadvantage.
Oh, yeah, sorry. Maybe we can have one last question due to time limit. So please go ahead.
So I think just it's kind of interesting. James and I talk about these kinds of things all the time. I'm going to say some of this is almost like a, streetlight effect measurement and so on. I think there's also a level of inevitability that's attached to this, and not for glorious reasons or not for bad reasons. So the first thing I'm going to point out, this process that you're describing, by the way, at Amazon, we have it at Cloudflare too. It goes all the way to the CTO, have conversations with him all the time. We're going to do this, and sometimes he gives me some leeway. Sometimes, like, what are we doing this for? I think fundamentally, I would love to see counterexamples to this. I claim there are only two ways that things get done. Either they are driven by money somehow, even if indirectly, or someone cares enough about it to push it through, which is most PhD students. And this comes back to James's comment about sitting down and writing a first draft. It's really not on the roadmap. You have to struggle to actually get it down. But at the same time, I think as a community, we fail to recognize that there are far more PhDs graduating than there are, let's say, faculty positions, which means there are going to be far more research-trained individuals working in industry, and that number is only ever going to grow. And so there is I think, like the potential is bigger, and so the outcomes are bigger, that of course more and more people who are trained in research and love it, who go to industry, will want to find ways to collaborate with people who don't go to industry. Measuring it is fine, but I don't think it's about, you have to do it, it's always great, or it's not. James pointed this out, we have way more internships that don't result in papers than we do in papers, and some of those are still highly successful, okay? So just keep these in mind as this, how we measure that matters.
Yeah, so I think there needs to be something happening on the corporate side as well. So because basically lawyers are risk averse, and there's absolutely no reason why they should accept even a small risk, right? So we faced this problem at Akamai a long time ago. We've been publishing in SIGCOMM for nearly 25 years. So the way we solve that problem is really to have really some high-level people with scientific backgrounds advise the legal team. Those people will have sort of a pretty strong push towards arguing for scientific visibility and things like that, and that changed the legal process. And there was a time like, I've been playing this role for a while now, and a lot of the papers will come and you have the ability to push legal in a certain way. So I would say that if you are a senior person in corporate, playing that role with your legal team would actually make a lot of difference.
All right. So thanks everyone. Due to the time limit, we have already running over time 5 minutes. So thanks for attending this session. I think it's a very hard discussions. So if you have any more questions or any more thoughts to share, you can just come to discuss it with our very nice speakers. So I will end up session here, and thanks everyone for coming.
Thank you, speaker.
Thanks, speaker, yeah.